Hi, I'm Jiahui. I'm a fifth-year PhD candidate at the Marine Robotics Group at MIT CSAL, and my advisor is Professor John Leonard. And for my thesis, I'm working on long-term object-based SLAM in low dynamic environments. So this incorporates two aspects. The first is the long-term and low dynamic sense, which means that a robot is expected to visit the same place over multiple sessions, and the robot expected to be aware of all of the changes in the environment so as to gain a conflict-free understanding of the world. The second is the object-based SLAM approaches. This is in comparison to the traditional feature-based approaches, which means that instead of leveraging all of those cumbersome lower-level geometric features like the points, lines, corners, and planes, we're simply processing the few measurements from the shape and the pose measurement from the objects and incorporate them into the traditional SLAM system to help the robots better navigate through the whole unknown environment. I feel the challenges of working in a long-term sense compared to the traditional short-term sense is that you get multiple visits to the same places, and the usual assumption of our SLAM system is that the world is static, which means that there are no changes in the environment. So as long as I visit this place multiple times, I'm simply accumulating my understanding of this, my observation of this environment. But in reality, as the world is constantly changing, and there will definitely be some changes happening in environments. For example, I moved my coffee mug from A to B, and accordingly, the map of this environment should be changed as well. So I think the first thing is that how can we deal with all of these changes to be, correctly reflect in the maps and also help the robot to just determine what's the subsequent proper action to be taken. And the second thing is that in terms of long term, which means that we'll get way more observations. For example, I'm observing the same room for a month, compared to one day, then I get tens of thousands of images and also point clouds and LiDAR, radar observations. How can we effectively derive the most useful information from all of this data I gather, as well as how can we store them in a most effective way? And also, sometimes I would say there's one kind of experiments that the map I'm going to build is possibly proportional to the time I navigate through the environment. So there might be times that I'm looking at a huge environment, like the 3-story high building, which means that there should be an effective way to store all of these objects as well as the floors and walls and everything in the most effective way so that we can save the memory to have low memory overhead. The traditional SLAM-based approach is usually feature-based, which means that we extract features from the images or the point cloud, and these features are usually, I would say, can be seen as a short summary of the points or the lines or the corners of all of those low geometric primitives that we can get from all of our observations. And usually, these features don't have any semantic meaning related to them. We need probably tens of thousands or even millions of point clouds to, I would say, model or to store the whole room. And then it's usually costs a lot of memory and probably is kind of cumbersome to process. But compared to them, the current new trend in SLAM is the object-based SLAM methods, which means that instead of deriving all of those information from the features, we are simply measuring all of the object level information, such as the pose, which means that, for example, where a chair is facing towards, and all the shape of the object. So simply using this, I would say, concise and effective measurements from just a few objects listed, I would say, you can see in the environment, and simply with that, we can still reach the similar goal of help our robot navigate and also build a map of the environment. And this is more close to how we humans think of the world. Once we can detect this is a chair and that is a table, this will also benefit some sort of downstream tasks such as manipulation and also, I would say, collision avoidance and everything, etc.